Hi students, welcome to the second part of the video for the lesson friction. Objective for today is to identify static friction. Before entering into the main topic, let's check the prior knowledge based on what we have learned in the previous video. In the first part of the video, we learned about what is friction. We learned which are the two factors on which the friction depends on. And we also learned about a special type of frictional force, that is the kinetic friction. So here are a few questions which you can answer. First question is, what is friction? As we have learned from the previous video, frictional force is a force that opposes motion between two surfaces that are touching each other. Second question, friction depends on dash and dash. It depends on the kind of surface and the force between the surfaces. Rougher the surface, dash the frictional force. Greater the frictional force. Coming into the main topic, the static friction. We already have learned what is kinetic friction. Kinetic friction is a opposing force acting on an object when two objects are sliding or if the objects are moving and they are touching each other. Okay, so it is a opposition force acting on an object which is under motion. Coming to static friction, the term static as such means at rest. So static friction is a force exerted on one surface by another when there is no motion between the two surfaces. It means the object is at rest. The force opposing the motion is the static. For example, in the image on the left, the force applied to the couch is balanced by the static frictional force. It means the couch does not move. So here a person is applying a force on the couch and the couch is not moving. If the object is not moving, the opposing force is the static friction. In the second figure you can see the person is applying force on the couch and the couch starts moving. If the object is moving, the opposing force acting on that object is the kinetic friction. We already have learned the equation for finding the kinetic friction. In the similar pattern, you have an equation to find static friction force. The static friction force Fs is equivalent to mu s times n, where Fs is a force of static friction, mu s is the coefficient of static friction, n is a normal force. Normal force is also represented as Fn or capital N, both are correct. The coefficient of static friction is represented as mu s, which is a Greek letter. So in general, static friction, for example, you push a piano and the piano is not moving. The opposing force acting on the piano is a static friction. Now if you apply a force on the piano and the piano starts moving, the opposing force acting on the piano is the kinetic friction. Now we have specified the term of coefficient of friction in both kinetic and static friction. Coefficient of friction is a measure or it's a value that gives you how much the objects or the surface can interact. If the value of mu, that is a coefficient, is low, that means the surfaces are very slippery. When they interact, they will slip. They are very slippery, that means the friction is very low over there. So if lower value of mu represents lower value of friction. High value of mu, That means the surfaces are sticky. When they interact each other, they stick. They are sticky. That means the friction is very high over there. So higher the value of mu, more the friction. And Fn or capital N is the normal force. We know that normal force is equivalent to the weight or the force of gravity acting on the object. Here are some values given for the coefficient of static friction and kinetic friction. Here it is specified as sliding friction. Sliding friction is same as kinetic friction, because in kinetic friction the objects are moving each other, touching each other. Okay, so it's also called sliding friction. So if you have, for example, rubber on a wet concrete, when the object is at rest, the amount of static coefficient of static friction is 0.75, and the sliding friction of the kinetic friction is 0.5. So this is a data which shows that each material has its own coefficient of static friction and coefficient of kinetic friction. Here there is a link which can give you more detailed explanation for these two types of friction, that is static and kinetic friction. Hope these two terms are very clear. Thank you.